Good evening, ladies and gentlemen, and very welcome to our session, Digital Winter Road Condition Information for Sustainable Cities. Let's see. My name is Hajin Karim, and I am a project and innovation manager working for a consulting company called PM located in Gothenburg. And I have nearly 25 years experience of working with road maintenance, road and rail maintenance in different positions and different roles. And together with my colleague, Bodil Sandén, we will lead this section this evening. And over to you, Bodil. Kindly, if you can present yourself.
Yes, hello everyone. My name is Bodil Sandén. I'm also a consultant and researcher. I have my own company called Co-Innovate, but I also work part-time at Karlstad University in Sweden. I'm just a backup technical support, and I will try to see what's going on in the chat room. If you have any questions, please comment on that in the chat, but you will also be able to ask them yourself at the end of the presentation. We are very curious who you are. Most of you have your names written, but some of you doesn't. So if you find yourself and use the mouse to point on your name, you can select more and rename, and there you can change to your entire name, and also we are curious of your organization. So please write that down if you can. I will. Thank you.
Thank you, Bodil. So, as you see, the program is mainly contain two presentations. The first presentation is about it's an introduction about Infra Sweden 23, a strategic innovation program with a focus on innovation within the transport infrastructure sector in Sweden. And the second presentation is about an innovation project called Digital Winter Road Condition for Sustainable Cities. And the project is a system and technology demonstration aiming at implementation of a new approach for winter maintenance in the Gothenburg city. This presentation will be in different parts. The first part is a presentation.
Erika.
Thank you. The first part in the presentation is an introduction to the challenges faced by the city of Gothenburg regarding winter maintenance. And this part also contains the short presentation about the objective of the project. And later we will have a second part, which is a presentation, an introduction to one of the applications which are used in the project to create road surface condition forecasters with the high resolutions. And after that, we will have a third part of the presentation, which is an introduction of an application used for follow-up of winter maintenance measures using friction measurements collected by a fleet of connected vehicles. And the final part of the presentation is a short description of the work packages included in the project and expected effects from an implementation of Digital Winter. And finally, we will have 20 minutes for questions and discussions. And I'm suggesting that you send your questions using the chat function in Zoom. And please remember to send the name of the speaker who want to ask and want to answer your question. And as we mentioned, the session will be recorded. So the first presentation as I mentioned, is the introduction about Infra Sweden 2030, a strategic innovation program will focus on innovations in transport infrastructure sector in Sweden. And the presentation will be given by my colleague Camilla Byström, Program Manager for Infra Sweden. Camilla has many years of experience from working with research and development in the infrastructure sector in different roles and different positions. So over to you, Camilla. The stage is yours.
Thank you very much, Havshin. As Havshin mentions, I'm the program manager for the innovation program Infra Sweden. And there are 17 strategic innovation programs in Sweden. And through collaboration in areas that are strategically important for Sweden, both companies, academia, and organizations can work together. And everyone who can contribute to development of sustainable products is welcome to apply for funding in our strategic programs. Next picture. And the scope for Infra Sweden is to develop and innovate the transportation infrastructure systems. And as we can see on the next picture, the roads and the railway system plays an important role for the development of the country Sweden. At the same time, we have to rely on to be able to maintain roads that is built many years ago, but we are also challenged, and we have to be able to provide new solutions for fossil-free transportation. And the next picture about challenges shows that the challenges that we are dealing with in the infrastructure sector are quite similar to elsewhere. We are dealing with sustainability and also digitalization as a tool for be sustainable. We are dealing with questions about urbanization, a service-based economy, new forms of collaborations, and also, of course, the security and the vulnerability of the system. And next picture shows what areas for innovation that we are working with. We are working with overall sustainabilities. And we are working with planning and building, and also developing materials and business models. And as I mentioned, and as we will talk about much more today, the digitalization as a tool for innovation and savings. And what we want to achieve in this program is to maintain an innovative sector that will succeed in reducing the climate impact. And we are doing that with construction of solutions for new methods for planning and building. But we also have lots of projects dealing with condition assessment and maintenance. And how do we do that? Our main tool for us as a strategic program is to have open calls for innovation projects. So we have more than 100 projects finished or ongoing, but we are also arranging innovation competitions, and we also initiate strategic projects and collaborations. And in order to reach innovation, we try to make our target groups to collaborate with each other. The collaboration is the key factor to come further than we have already done. So our target groups are owners of the transport infrastructure, and also both large and small businesses that could contribute, and of course academy and research institutes, and also innovators in the sector or of the sector. And at this very moment we have an open call that will close in the 2nd of February, and the scope for this call is to find solutions for faster conversions to sustainable transport infrastructure. And in a call, we normally have a 3 times amount of projects that search for funding than we could offer. And I guess you wonder what kind of all projects that we have, what are they on? They are on everything you can imagine in innovation in the transport infrastructure sector. And for example, one of our projects called iBridge, and the overall goal is to come further with sensors and map how sensors and measurement technology can best complement and replace manual inspections. That project has come very long, so maybe we can use that quite soon in Sweden. Another project is called Waybreaker, and it has to do with noise dampening effects. So we can build closer to railways and roads and so on. And we also have projects on the building phase. For an example, automated construction. The purpose is to improve the construction sector and also be able to work with industrial robots. Next project you will hear more about, dynamic forecast controlled winter road maintenance. So I skipped that, just a teaser. And in the tunnel project TAC, we investigate how new technique can detect cracks on tunnel lining in order to find out where to repair it faster and easier. And in the project Smart Cement, we searching for the ideal solution for monitoring concrete structures and to develop a conductive concrete with self-monitoring capability. This smart concrete can then be used for entire structures, or it can also be used in old structures to repair, and it's at the moment tested in a pilot. So we do have many projects and many interesting and inspiring results, but that's all for this introduction. So thank you very much.
Thank you very much, Camilla, for an interesting presentation and introduction about Infra Sweden 2030. And now is time for introducing our innovation project, Digital Winter Road Condition Information. This is a project financed by Infra Sweden 2030 in cooperation with the City of Gothenburg, Nira Dynamics, via PM Klimator, Vaisala, and Luleå University of Technology. And as I mentioned before, the project is a system and technology demonstration aiming to evaluate and implement an efficient and sustainable approach for winter maintenance in Gothenburg City. And the first part of the presentation is an introduction of the challenges faced by the city of Gothenburg regarding the winter maintenance and purpose of having the project. And for this reason, I would like to give the stage to Håkan Johansson and Olivia Nilsson to talk more about the project. Both Håkan and Olivia are working as a planning officer with many years of experience from working with road maintenance and different roles and different positions. And both of them are working for the Urban Transport Administration in the city of Gothenburg. So over to you, please.
Thank you. Yes, my name is Håkan. And as Hashim said, I'm working as a planning officer at the Urban Transportation Administration in the city of Gothenburg. And I'm head responsible for the winter maintenance in the city, together with my colleague Olivia, who can present herself.
Hello, my name is Olivia, and like Håkan, I work as a planning officer at the city of Gothenburg. And I'm responsible for some of our contracts covering bare ground and winter road maintenance. And I have a previous experience as a project manager at the OF, now called AFRI. And before that, I took my master's at Chalmers. Next.
Next slide. Some background. Let's see there. The slide before. Shall we take that, Hajim? Or it's that? Today we will talk briefly about the background of this project and why we saw a great need to start this project for just over a year ago. We have for a long time felt a great need to improve winter road maintenance in the city. Not least as well as we in the city of Gothenburg have combined car and tram traffic of several streets, which make the winter road maintenance a little bit more complicated. Then we also have political decisions in the city that we should promote winter cycling as a part of achieving an emission-free city. Therefore is this project a very important part of the city of Gothenburg development town of a more efficient winter road maintenance and sustainable urban development. Olivia, you're next.
Yes, you can keep that slide, Hashim. The previous one. Thank you. And like many other cities in the world, an efficient and sustainable transport system is one of the high prioritized areas by the city of Gothenburg to achieve a sustainable development. A sustainable transport system, in turn, requires efficient and sustainable maintenance, and specifically road winter maintenance. During winter, with varying weather like snow, ice, rain, and storms, Exact and efficient response from the city is required. However, it's easy to demand snow and ice-free roads everywhere and all the time, but it is very difficult and expensive to achieve. In order to have a cost-effective, efficient, and sustainable winter road maintenance, we need three things mainly. The first is effective tools for road surface forecasting to get an overall picture of the road condition throughout the city. Secondly, we need decision support system with tools for action planning and conduction of winter maintenance measures to enable the right actions to be taken at the right time and places. And last, we need effective methods for follow-up of the measures and the effect of the measures to be able to control compliance with our contractual requirements. With this said, how does it work in reality? And that we will talk more about in coming slides.
Today's winter road maintenance. We have in the city road operators. We are responsible for approximately 3,000 kilometers of road network, which consists of roads, cycle paths, sidewalks, and other surface. During wintertime, high demands are placed on winter road maintenance from both citizens and visitors. We do what we can to ensure that the municipal road is passable and safe. However, we can never guarantee 100% non-slippery roads. Between October the 15th and April the 15th, we have our winter organization running, meaning we have people on standby round the clock to ensure that we are always ready if the roads needs to be plowed or de-iced. This requires planning all year around, as well as a lot of resources and a lot of cost of money for this. And most of 1/3 of the winter cost is in, let's say, personal and equipment and drivers expenses. Thank you. Next slide.
Yes.
During our winter period, we also have continuous follow-up of the forecast data via weather stations. Monitoring weather data is an important part of the winter operations and also a crucial tool for decision making. However, the weather data is only collected from a few weather stations around the city, meaning the information they provide is not representative of the entire road network. Also, the stations are deliberately located in places that are climate exposed to capture high-risk areas. This means that the winter road maintenance often is being based on a worst-case scenario. We also have a start criteria, which is the criteria that must be met in order for an action to be started. And today the criteria for plowing is 2 to 3 centimeters on the main streets and 5 on the local streets. And this criteria is also very dependent on weather and time. The climate in Gothenburg is very humid because the closeness to the Atlantic. And we also have a large altitude differences in the city. This means that we sometimes can have 10 degrees below zero in the eastern parts of the city and plus degrees by the sea. And this, of course, affects the road conditions extremely much and makes the road conditions difficult to assess. It also means that we sometimes have to plow or de-ice in certain parts of the city, while in other parts, no actions has to be taken. Next.
We also have criteria today for action times. From the start of a route until the plowed and the ice. We expect an action time per route and unit of 6 hours. And if the continues to snow, they have to start a new route. This action time is affected by the length of the snowfall as well as the amount of the snow. We have recently started using quality and following up system with GPS tracking on one of some of our routes. We see several benefits with this. We can follow drivers when they can follow their own route in real time, and we see immediately when an action is performed. We have road officers to do inspections after each snowfall to see how well the contract's requirements are met. We have also recently started with requirement of certification for winter staffs. This education provides knowledge of how the winter maintenance in the city shall be carried out, as Gothenburg is a complex with mixed car and tram traffic that goes by different legislations. This certification shall be renewed annually. Next slide, please.
To conclude, we can say that the winter road maintenance activities are planned, carried out, and followed up on the basis of inadequate road conditions forecast and subjective information about the road conditions. We have a few weather stations, but they are few and not sufficient as a basis for decisions. And the quality and follow-up systems with the GPS tracking is good, but it doesn't provide us information about the outcome of the actions that we take. In order for us to be able to improve the city's winter road maintenance operations with both the increased resource efficiency and traffic safety, as well as reduced negative environmental impact, we see a great need for the implementation of digital tools, and therefore we are very happy and positive about the changes that this project eventually will bring. Thank you.
So much. To face these challenges, we have started this project called Digital Winter Road Condition Information with a cooperation with the city of Gothenburg. The project is a system and a technology demonstration aiming at the evaluation and validation the benefits of using digital winter road condition information to achieve an efficient and sustainable winter road maintenance in the city of Gothenburg. And the objective of the project is, as I said, evaluate the use of digital winter road condition information for planning and follow-up of the winter actions and activities with a focus on reliability, efficiency, limitation, benefits, and costs. We also have a goal to create a condition or create conditions required for the implementation of the digital winter road information at the Urban Transport Administration in the city of Gothenburg. So short about the project and the objectives and how does the system looks. Here is a picture explaining the ecosystem of digital winter road condition informations, a combination of sensors, stationary sensors and mobile sensors used to collect data about the road condition or road surface condition. And this data then will be combined with the weather forecasts to create high resolution road condition forecasts or road surface condition forecasts. This information then will be used as an input in a decision-making system to find out what kind of action has to be taken and where and when. And this information then is sent to the contractors to take a right measure, right action in the right place at the right time. And when these measures are conducted, then the information will be sent by the contractor to the urban transport administration at the city of Gothenburg to give them more information about the actions and picture of the current condition. At the same time, more information about the road condition is collected in form of friction measurements collected by a fleet of connected vehicles in the city. Thousands of vehicles in the city using current or existing sensors to measure the friction, and this information is then sent to the urban transport administration and used for different reason or different application. One of the application is to follow up the actions and the outcome of the actions, and follow up the fulfillment of the condition in the winter maintenance contracts. And this information can also be used for traffic management reason in a proactive way. So this is a short description of how this approach for the new approach for winter maintenance is functioning. And one of the necessary inputs to this new winter maintenance approach is the high resolution road condition forecasts. One of those applications used in this for this reason is provided by Climatology AB, and I would like to ask Tobias Nordgren to give us more information about the application. And Tobias is a director of international partner and Climatology with 17 years experience from working with digital transformation in different domains. So over to you, Tobias, please.
Thank you, Hashim. I would like to see if I can share my screen.
Yes.
Make sure that it works okay.
Yes.
Great. Okay. Hi, everyone. My name is Tobias Nordgren, and as Hashim said, I work at a company named Climatology. Climatology's part in Gothenburg's digital winter project is focused on the road condition forecast, which is a necessity for the maintenance organizations to be able to plan their actions and organization for what's to come. This will just be a short 10-minute crash course on road condition forecasting. I will explain a little bit about Climatology's background, some basics in road climatology, show what is needed to make a world-leading road condition forecast, and also explain how that is transforming the businesses around us. So who am I? Hashim just told you that I have some experience in digital transformation in 3 different domains, and they range from military training and simulation to intelligent transportation systems and now road winter maintenance. But the common objective, no matter which domain, is to improve the effectiveness and efficiency by moving away from subjective opinions to fact-based decision making. But first, short background about Climatology. You can say we are a startup in an old man's suit. The foundation of Climatology is based on more than 30 years of research in road climatology. This research has been internationally recognized, and our founders, Torbjörn and Jörgen, are the creators of this specific field of research. With this research and an idea to create safer roads, they set out to start a company in 2001. Today, we have more than 800 daily users from 7 different countries making use of our road condition forecasts. The customer base is wide, from smart cities to road winter maintenance organization and car manufacturers. But before we go into road climatology and forecasting, we need to understand the difference between weather and climate. Weather are the short-term changes in the atmosphere. That's what happens outside your window right now. You can see the weather forecasts in your app or in your TV. Climate, on the other hand, describes the average weather conditions in a specific area over a long period of time, 30 years or more. You understand the difference? Weather, short-term changes in the atmosphere. Climate, long-term weather observations for more than 30 years. Road climatology is about what happens on the road surface in a specific area, like on the winter road picture to the left. The road climate for the road stretch depends on several parameters, such as topography, weather, and solar radiation. All these parameters on unique road segments are categorized. Imagine your country's national road network, thousands and thousands of kilometers of road, divided into small segments, combined with 30 years of climate data for each unique road stretch. Then you have the first piece of the puzzle to make a road condition forecast. The next pieces of the puzzle is to combine road segment characteristics with multiple other data sources, such as road weather stations, vehicle data, and weather forecasts, and other relevant sensors. All this data is combined into rule-based models, which are based on Climator's research in road climatology, models that has been developed and validated over a long period of time. We add machine learning to do the validation of our data sources and continuously support us in improving the climate models. For example, before setting up a new road network where we want to make forecasts on, we validate our models within this specific area with years and years of historic data before launch to the customer. This results in a world-leading road status forecast up to 72 hours, telling you what will be on the road surface on that specific road segment with high confidence. Here's an example. This is a picture from our road status information system, and this is the city of Gothenburg. This is a simplified example I will do, but if you see the orange road network, that means that it's ice. And the green road network means that it's wet on the road. The west part of Gothenburg is heated up by the closeness to the open water. The road temperatures are above freezing point. But further east and a little bit to the north, it's not the same microclimate and the roads are colored orange. Road temperatures are below zero and it's ice on the surface. This enables the road maintenance operator to put their full efforts on the orange roads for de-icing treatments and making the roads safe to travel on again. But to implement a data-driven decision support system into an organization it's not always that easy. And we have great respect for maybe the needed change for ways of working, maybe new business rules, not to mention the time it takes to establish trust with a new system. Nevertheless, we continue to transform the winter maintenance industry to reduce the risk of accidents due to bad road conditions, such as these. Right now, there are a lot of changes going on within this industry that defines a big transformation. There are precise road weather forecasts that saves the resources, such as the usage of salt, diesel, and vehicle hours. Less resources used means reducing the environmental impact and contributes to the environmental goals. New business models are launched from between road authorities to contractors. Technology development focus on dynamic salting, dynamic routing, and even further down the road, even autonomous maintenance vehicles. This is why Climatology is so engaged to continue to invest in the research and the customer dialogues. We are only in the beginning of a huge transformation. But in the end of the day, we are all here to create safer roads, limit the impact on the environment, and contribute to a sustainable world. And this is the end of my presentation, and I thank you for your attention.
Thank you, Tobias, for an interesting and good presentation. I'm trying to share my screen again. Let's see. How can I do that?
هون والله حاولنا سيميناري كي اونلاين اجا
Again, there it is. So, go to the presentation mode. So, yes. So another important input to the new approach of winter maintenance is information about the road condition collected by fleet of connected vehicles. And this information is in our project is provided by Untitled Technology. To know more about the application, I would like to ask William Johnson to take the stage. And William is a product owner for Winter Road Insight at NERA Dynamics, and have a long experience from working with digital transitions and system engineering. So please, William, over to you.
Thank you, Hashim, and I will try to do as Tobias. I will try to share my screen, and in order to do so, I think, yeah, you have to stop sharing.
Yes.
And now maybe the most complex part, the most complex technical part of this presentation is to be conducted, and that is to bring my presentation to the right screen.
Yes.
And I think you can see it accordingly now.
Yes.
That's great.
Great.
So my name is William Johnson. I am currently the product owner for what we call Winter Road Insights at a company called NERA Dynamics, which is based in Sweden. Short background about NERA is that NERA was founded around the year 2000 from one of the biggest universities in Sweden, Linköping University, and it was a spin-off from a professor called Fredrik Gustafsson, and he is a professor in sensor fusion. And the spin-off he did was to estimate and measure the tire pressures using only current sensors in the vehicles. In more detail, not installing dedicated sensors for pressure measuring. So he was inventing new algorithms that was using ABS braking sensors and so on to get indications if you need to inflate your tire or even deflate your tire, of course, and detect punctures in early stage, which then became a legal requirement in the European Union, in the US, and also has been in the Asian, especially Chinese market for a couple of years ago. But that's not exactly where I'm working. I'm working at the 5 years now. This business unit has existed at NIRA, which is called Road Perception. And of this business unit, the Winter Road Insights part is, or product area is part of the Road Perception business unit. And that's where I'm the product owner. I will go into a little bit more detail what we mean with Winter Road Insights and what our products can benefit an end user and winter maintenance operator with in a few minutes. But just to conduct my profile, I have been a product owner for a few years at NIRA, and I am currently also a member of the Transport and Urban Planning Committee in Östergötland, the regional one. I have been a product manager at NIRA and been a systems engineer. And during this time, I have been part of both developing our technical solution, putting them into the market, doing digital transformations and supplying of services together with Hashim and other parties in order to both get this technology right to fit the end customer needs and also transform the way of working. My main responsibility has been as a product expert and managing the technical details there. So NIRA Dynamics, the core foundation of the company is to only do software. We have some hardware internally to do analysis and to collect data and so on, but the products that we deliver to our customers is software based. And our core concept is to use only existing sensors. So we don't put any sensors into the vehicles, or we don't put more vehicles onto the road or something like that. We use what is there and try to generate additional information, or just capture this information, press it in a usable way. And especially what we do in the road perception unit is to install these algorithms, which is taking the current sensors within the vehicles, processing that information, and then we're sending it to our cloud. And within this cloud, we are processing it and visualizing it and packaging it for different customer segments that can be used for different applications. So this is a brief look on our processing chain. So let me just enable the pointer here. So over here, we have the data collection side. So we are installed in the Volkswagen Group brand. So namely the Volkswagen brands, the Skoda branch, the Seat branch, the Porsche branch, and the Audi branch. And we install our algorithms into the core processing units of these vehicles when they are leaving the production plant. So they are installed during series production, and when they are rolling out and is sold to the end customers, these algorithms is active in the vehicle. And they start to send data to the vehicle manufacturer backend, and they are sending this information further on to our backend in real time, with a very, very minimal delay in the data processing pipeline. We're combining this with both observed data and third weather providers. And this information that we are collecting, we are creating a friction map, we are creating a roughness map, we are having weather-related maps regarding air temperature observations from vehicles, humidity observations, sun influx observations, and so on. And all these map layers we combine into different product segments where they can be used into asset management of the repavement business. It can be used into the winter maintenance business in order to react very fast if anything in the decision-making process goes wrong, or if there are any misprediction in snowfall or something like that. You can immediately get information and react accordingly to keep the performance levels of the road network. We do also deliver this to the automotive industry, where warnings can be seen if any vehicle in front of you have observed a warning. It can be sent up to the cloud and redistributed to basically every vehicle that wants to consume this information in order to get a heads-up notification in your dashboard, and then reduce your speed or be more aware when you're driving and so on, and by that increasing safety, both from the winter maintenance side in order to ensure that we do have the optimal performance of the road network, and also informing the driver of the individual vehicle so they can also react accordingly if there are any deviations from extremely good standards, basically. We can briefly say we have 2 million vehicles that have been rolling out the production ban. We have about 50,000 in Sweden that is scheduled to provide and collect data. These vehicles are located into the North America and the European region, and all this information is of course fully GDPR compliant and have been reviewed and revised in every legal manner in order to ensure legal compatibility with all requirements. So what does this algorithms actually do? So we have a left and right view here. So the left view shows early state project that we had in Gothenburg during 2019. It was a quite extreme snowfall that was coming over Gothenburg. I think it was in January 2019. And what can be seen here is a traditional way of making slippery detection. So it's based on ABS and TCSs only. And we can see on the small road network, we do have some dents, and especially close to the corners and so on. These are quite small roads and very located to the corners. And on the bigger connecting roads within the municipality and so on, we do have a lot fewer measurements. And on the big European highway network, we have basically 0 measurements reported. And we should note that this is what was one of the most slippery days in 2019. And if we do the same thing with this kind of new virtual friction measurement algorithms that is using the current sensors from the vehicle, but is measuring the friction potential even during very, very limited acceleration and normal driving conditions. The wind force and the resistance from the wind can trigger these measurements in a very dense way. We can see that we get a totally other overview of the road network with very, very high coverage. And this is generated with only 180 taxi vehicles in Gothenburg. And now we do have about 5,000 personal vehicles or private vehicles that is continuously collecting this data. And we are continuously rolling out more vehicles in order to improve the coverage. And we can see that this data, and as Tobias said, having data makes you guy actually saying something rather than having an opinion. We can see the difference between at the first stage we do have 0 data, and at the second stage we have this very easy algorithms based on ABS and TCSs, and currently we're transforming into a very, very dense and huge amount of data that can provide the end user with very, very detailed information about the road maintenance performance. So what is NIRA currently providing? We are currently providing packages or product packages within 4 areas. We do have the simplest one that we call a follow-up package, which looks at how well is the winter maintenance work being performed within a specified region. So we are taking these friction measurements and comparing to contractual and legal standards and agreements. And we are finding deviations from there that can be used both to, at the first stage, discuss and improve the operations, and also the fact-based approach if any contract or payment or something like that has to be discussed. It can also be used if you get complaints that are not well founded. It can be used to not focus your or direct your operations to anyone that is being very loud, and calling to the municipality or the government or something like that to attract attention. You can be fact-based on where you direct your winter maintenance attention. We do have a very closely related area that we do call KPI and historical evaluation. And this is more of performance measures where we do provide a KPI. We do have this historical evaluation where we can map together weather events together with friction deviations and slippery conditions. And you can start to understand during storm scenarios, or when you have a severe event, you can start to understand if we did it like this, can we look at the map and see if we can do it in another way to get better performances? Or during a whole season, we can see, do we have different regions within a city or within a country that is performing differently? And do they have different approaches, different strategies regarding salt amounts when they go out, different tools, or what are the difference? And we can start to understand what is the best way to do it and how can we learn and improve from each other and our neighbors. We can also see if there are any problematic spots, example, bridges or cold spots that has reduced temperature, which means that we have higher probability of freezing due to the low temperature, or higher probability of condensation from the air down to the road and creating wetness on the road. Do we have such spots on our network that is more prominent or more prone to being slippery that we do not manage accordingly, or do we have them and we think that we manage them accordingly? That we can see into this KPI and historical evaluation tools. Since this information is collected in real time, we do provide tools and map layers that is a live network status, which means that even though if we are doing it like you and me currently, we're sitting in a chair at our desktop, we can have a full view and a full overview and a very good understanding of our current status of the road network without going out and do manual inspections, subjective conclusions. We can have an objective current status of the road network, and we can react extremely fast if we need to do anything on the road network, and if we see any deviation. We have seen cases where we can see this a few hours before occurrences of accidents due to slipperiness, which if you have a turnaround time of your winter maintenance of less than 2 hours, we can prevent several accidents in the European countryside. And we can see that for some bigger actors on national level, we have found cases where we can detect severe slipperiness, where you have basically no skid resistance, and prevent it and remove 8 hours of extreme slipperiness in some cases. So this is a very, very powerful tool to not change your operations and increase the costs by doing more inspections. You can rather sit down and be laid back and see that your road network is okay, and when it is not, you can react instantly. And we have even automated this with what we call a slippery alert. So you don't even have to monitor this application anymore. You can get a notification in your phone saying that you do have deviations on your road network. Please go into the tool and have a look where and decide if you want to act. So we have and are trying to automate this process as much as possible. And we're trying to reduce the amount of time from when a deviation from a standard secure until it can be resolved in order to increase or maximize the performance and safety on the road network. The last slide, a very brief overview of the tools that we provide. On the left, we have this live map where we can see and detect instantaneous road condition deviations. So red means that there are slippery conditions and green means that there are good conditions. And when you get red, an amount of red on your map that you're not confident to have there, you should of course go out and do winter maintenance or at least inspect it. We do have these notifications on regional levels. We can provide this on parts of cities. We can provide it on city level. We can provide it on regions, and we can provide it on whole country level as well. And on the right, we see the follow-up and historical evaluation tool, where we can select periods of time, we can select areas, sizes of roads, limits for what we define as slipperiness, and get a report and aggregated view to understand where did slipperiness occur. And we also put this together with observed weather conditions from vehicle in order to understand, was it most likely due to snowfall, or was it cold, or what could be this case. And we are ranking these occasions based on how much slipperiness that was observed during a specified road network. So that was the end of my presentation. Thank you for listening, and this is only the beginning of transforming our winter maintenance operations and way of working into a more digital way that will hopefully and most likely both cut costs and increase the outcome of the operations. So thank you everyone, and if you have any questions, feel free to ask them in the chat, or my email address will be in the end of the presentation. So just reach out if you have any consideration or want to discuss any details or anything. Thank you.
Thank you, William. And back to share my screen again. Presentation. If you can see more. And yes. Let's see. So what about the effects of this project in connection to the global goals on for the sustainability? But before going to these effects, to measure these effects, I would like also to say something about the work packages and how we are working in this project. And as many of you knows that a new technology cannot be considered as an innovation unless the technology is implemented. And to ensure the implementation, there are different conditions which are necessary to create. And those conditions we are talking about for digital winter are mainly related to the end user or the staff using this application, and it's also related to adoption of organization and adoption of the regulation. When it comes to the end users or the staff working with the winter maintenance, we have regular meeting with the staff at the Urban Transport Administration to give them more knowledge about how to use these applications and to support them in the daily basis activities. We also have regular meetings for feedbacks and follow up the way that the staff using this new approach. And doing that, we hopefully can support them and make them more convenient to shift from the old technologies to these new applications. And when it comes to adoption of the organization, we have a work package with a focus on identifying and implementing of those adoptions required in current IT systems. And this is mainly to make the current IT systems compatible with the new applications in order to create abilities to handle, process, receive this kind of data, and to be able to make right analysis and use and utilize the data right way. And when it comes to the regulation, which is a very important part and a very important condition to make sure that the application could be applied or implemented. When it comes to that adoption, we have a work package aiming to identify and implement the necessary adaptation of the regulation for the winter maintenance according to this new approach. The current regulation, which you heard about today, was developed before 20 or 30 years ago, and it's not compatible with this new approach, especially when we are talking about a great number of information about road condition, which will be very hard to apply with the old regulations. So as you see, there is many efforts when it comes to create conditions for implementations. And I would say some words about the effects of this innovation, especially when it comes to a resource-efficient winter road maintenance operating based on optimized winter road maintenance due to better tools for planning and performance and follow-up for maintenance measures. Another effect of this innovation is a good understanding of current road surface condition, which leads to a better decision and prioritization regarding traffic management in a proactive way. And you heard a lot about both the applications, one for forecasting and the other one for following up the friction on the road in the city of Gothenburg. Another advantage of this application is the reduction of negative impacts of winter road maintenance on the environment through reduced use of anti-slip agents and reduced emission from the winter road maintenance vehicles, as we use this application to optimize the winter maintenance actions and only take right action in the right place at the right time. And another advantage is the reduction of traffic accidents related costs through increased traffic safety and reduced risk for slipping due to reduced risk for slippery roads due to an efficient winter road maintenance. And we heard much about that where Tobias and William explained about the advantage of these two applications. Another advantage is the improvement in the work environments as a result of better decision support tools for the road maintenance staff. Hopefully this will also result in increased gender equality by making the road maintenance sectors more attractive due to a better and modernized working environment. So looking at those advantages, we are very sure that this project will be a great contribution to the efforts made by the city of Gothenburg to reach the sustainable, the global sustainable goals by 2030. So this was my last slides and the last slide for our session, and now it's time for questions. So please feel free to ask any question about the project. And if you have any question also about the Infra Sweden, feel free to ask, please. Bodil, have we got any questions in the chat?
We have had one so far. It was Rosipe who wanted to know more about the smart cement project that Camilla told us a bit about. But I'll share the contact information to the project leader, and hopefully you two can get in contact with each other so you can learn more about that project.
Is it okay to take questions orally?
Yes, go ahead.
I'm interested in, you have presented a lot of advantages here with this project. If you look at it in a cost benefit way for Gothenburg as a municipality, or even for the whole country as Sweden, what of all these advantages do you think is the largest? Is it the one that you reduce accidents and mortalities, or is it saved costs, or is it advantages regarding the environment, or even, as you mentioned, the equality between genders? Have you done any cost benefit analysis on which of those advantages do you consider the largest?
Okay, William, you have this part of the analysis in your work package. Would you like to answer?
Yeah, and the short answer, Anders, is that is in the plan, but it is not conducted yet. So this is a 3-year research project, and we are on the first year now. And the first part of this will be to ensure that we get everything up and running, that everyone understands the applications of all the systems. So we have a good foundation, and we have started the benefit analysis part as of 1 week ago, where we will have a thesis worker doing his master thesis work into analyzing these benefits. So we have a brief overview of the potential in some of these areas, but we have to get back in the ranking of these when we have done the investigations, and those will most likely be done in the upcoming 4 or 5 months.
Oh, thank you very much. Then we'll get back to you within half a year or so. Another similar question in all these benefits or advantages. You have it's a complex project, and you have several crucial actors within the project. Really, I have 2 questions. One is regarding how to manage all these actors to collaborate to achieve these common goals that you have, because some of the actors might even be competitors. And then I see both organizational problems and technical problems, and obviously you have already come a long way. What do you think are the most important success factors to reach your goals? So there's 2 questions. One, how do you organize to make all the actors to work together to achieve the goals, and what are the most important success factors?
Okay. Who want to answer?
I can answer that. The most important factor for succeeding in this project is understanding between the parts. And each part has responsible to make this project to a success. And to do that, we have to have faith in each other. That's the main thing to succeed in this. And if we have any problem, we talk about them. And so we have done, and we will do in the future as well.
Yes, I can add in, and from my point of view, all the parts in this project, both the parties and everyone involved, has a very high commitment to delivering according to the project's objectives and goals, and to ensure that the city of Gothenburg both gets a clear view of the benefit and the implications of the systems in questions, and also a decent implementation plan within the processes and the current IT systems. So everyone has and is committed to the objectives and the goals of this project in order to provide a good conclusion in the end of these 3 years. And I think that is very important on top of what Håkan stated.
Great.
Thank you very much.
Great. You had another question, or two questions, the last question, or I understand?
Yeah, the other question, I think you answered both of them, actually, Håkan and William. It was regarding the collaboration and the success factors. So I'm satisfied. Thank you very much.
And I can also add that the cooperation between the private sector and the agencies and academic is kind of existing in the DNA of Swedish people. So it's challenging, but it's always solved in one or another way. So, any more questions? No? Okay, then let's summarize the session. And as we started this session with an introduction and presentation about the Infra Sweden 2030 with a introduction to the goals of the program and the effects that expected to give, and some examples about projects which are financed by the program. Very interesting presentation, and if you have any questions, so please feel free to send it to Camilla. It can be about the projects financed by the program, can be about the financial possibilities and cooperation with the Swedish actors when it comes to innovation in the infrastructure sectors. Then we saw a presentation about our project Digital Winter Road Condition Informations, started with an explanation or a description of the challenges faced by the Gothenburg city and how they are handling those challenges today, and how they are thinking to do it in the future using the digital winter road conditions. And then we saw a presentation about the different applications which are included in the digital winter road conditions, starting with a description about the forecasting and the planning and decision making systems. Very interesting presentation describing how the forecasters are made to have a good decision-making system. And then we have a interesting presentation about the connected vehicle fleet and how they are using the existing sensors and the systems, safety systems, to create friction measurements as a important tool to follow up the winter maintenance measures and for different other application as well. And finally, we saw a short description about the work packages and the aspects that are included rather than the technology to ensure successful implementation of the this new winter maintenance approach and the effects expected from the project and the implementation of the new approach for winter maintenance. So with this summary, I would like to thank all of you, the attendants and my colleagues for these nice and interesting presentations. And if you have any questions, please don't hesitate to contact us. Here you have the contact information or emails for the speakers for today. And finally, on behalf of my colleagues, I would like to thank you again for attending our session, and have a nice evening if it's evening. Thank you very much.
Thank you so much.
Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you.